Hi friends, welcome to follow up. In this video, we're going to look at problem 3016, minimum number of pushes to type word. This is the second of such problems. In this video, we're going to explain a strategy based on greedily assigning according to decreasing frequencies. As for coding, we're going to use weighted sum and the zip function. First, we're going to digest the requirements or the problem statement, and then we do the analysis, and finally we share the code. So if you have checked out the video for problem 3014, so it would be great to continue this coding here. Here we are given a string word containing lowercase English letters. So here we do not assume that the word contains unique characters, right? See, in other words, a character can appear multiple times in this word. So the keyboard or the lowercase English alphabet can be mapped to numbers 2 to 9. So this 2 and 9 both inclusive. The keys can be remapped to any amount of letters, but each letter must be mapped to exactly one key. And we need to find the minimum number of times the key will be pushed to type the string word. So that's the problem statement. So here we have several examples. So this example is the same as the example 1 for problem 3014, right? So we're not going to explain more. So for the second one, that's different. So here we have 4 copies of X, Y, Z, right? So for this, basically, the unique letters are X and Y and Z. Both appears 4 times, right? So the more a letter appears, we want to push it less, right? For example, for X, Y, Z, we can map to, say, 2, 3, 4, right? So we just choose 3 numbers out of the 8. So each letter we just need to push once, right? X we need to push once, but we have 4x, so we get 1 times 4, right? So in other words, the number of pushes times the frequency. Similarly for Y, for Z, so we're going to get 1 times 4 plus 1 times 4 plus 1 times 4. That is 12. So if you look at this example, right? So you can check the number of, let me maybe print out those. Maybe it's better. So I'm going to print out the collections counter, right? So this string. So it will give you the unique characters and their frequencies. So here we see, meanwhile, let me also print the length. So let's say length. So let's check how many unique characters are there. Right. So, so here let's make it aligned. So we get 9 characters, right? So here I appears the most time. So we can look at the first 8 unique characters. So we use a frequency from large to small. Then for the first 8 characters with higher frequencies, we can map to 2 up to 9 respectively. So for those letters, we just push once, right? So the number of pushes needed is 1 times 6 plus 1 times 2 plus 1 times 2 plus 1 times 2. Then the next character, we need to map to, we can map to any number, right? So this we need to push twice, right? But because the frequency is 2, so we're going to have 2 times 2, right? So overall, what we have, actually we have 6 plus this 7 2s, right? 6 times 1 plus 2 times 1 up to 2 times 1. So then for the last unique character, we need to push twice. So we have 2 times 2. So overall, you have 6 plus. So here we have 7 2s. Here we have 2 2s. So overall, we have 18 tools, right? So we have 9 tools, that is 18, right? So we have 24. That's the return for this problem, right? So with that said, let's also look at the constraint. Here the word length can be as long as 10 to the power fifths due to the non-existence of distinct character assumption, right? A word consists of lowercase English letters only. But here the thing is that we have at most 26 lowercase English letters, right? So that's actually the part or the point we need to notice. So with that said, we are ready to do the coding. We just need to follow this pattern here, right? So the first thing is to get the counter. Let's see, I'm going to use a collections counter, right? So the word. So this dictionary will contain the key will be the unique words and unique characters, and the value will be the frequencies. So we are only interested in the frequencies, right? So let's get the frequencies. Also, we are going to sort them from high to low. Sort, let's see, sorted. So the values. So then we are going to do reverse, maybe. Let's see. So this way, for this example, we are going to get 6 followed by 8 tools, right? And then we know that if we have 26 characters, so let's say m pushes, right? So the first 8 will be mapped to the first in each key, right? So we're going to have the number of pushes needed is 1. So we get 1 times 8. And then the second 8 characters will be pushed to 2 times 8, because each we need 2 pushes. And the next 8 characters each will need 3 pushes. Well, for the last 2, we're going to need 4. Yeah. So, and then because we have already sorted the frequency from high to low, yeah, we're going to just, if you have less than 8 frequencies, so each character just pushes once. So you can, so here in this problem, so you are going to have something like, let me put it here. You are going to have 6, 2, 2, 2, 2, 2, 2. So this is how many tools? This is the 7, 8. We have this number of tools. And then for the first 8, you are going to have number of pushes is 1, 1, 1, 1, 1. And for following ones will be 2, right? So then we just do summation of the number of pushes with the frequency and then sum them. So notice that here in this the frequencies, the length is bounded above by 26. It depends on the word length. For example, here the length of these frequencies will be 3 because we have 3 unique characters. But here m pushes has a length 26 always, right? But this if I use zip function, it will use the short length, right? So here, let's see. I just need to return the summation, the frequency times m push, right? The frequency is here, the push is here. Then for frequency and m push in zip, right? So frequencies and m pushes, right? Then because the m pushes will be longer or equal to two frequencies, right? At most they're equal. In general, this will be longer. And then the length of this zip iterable is the length of the frequencies. With that said, I guess that's it for the solution for this problem. We can do a test. It passes this example. Now let's look at the generic case. Yeah, it passes all the cases. So here, actually, I specified some pushes list, and then I do weighted sum, for the frequencies. But you can just use this on the air, right? If you like, you can further simplify the code. I guess the code for now is compact enough, so we will content ourselves with this format. for pedagogical purpose. So with that said, I guess that's it for this problem and for this video. Thank you.